So any object vector, this one, really create that space. Okay? Understand that? For example, let us look at example. So I hope you already copied my writing on the board. I'm going to give you a simple example here. All right? Assume. Right. Assume I have a V0K equal to, alright, that is, my V0K is 1, 0, 0, 1, and 0, 1, 1, 0. Okay? Right? Now, if I times a CK1 and CK2. Okay? And then I have CK1, CK2, and CK2, and CK1. Right? Yeah, that's only a vector. So any arbitrary, so these two vectors create a space. That space, you have this property. Any arbitrary K1, arbitrary K2, arbitrary K2, arbitrary K1, then this vector is inside this space. Okay? So now, that is my phi k. So this is my phi k. Now the problem is, what is the best CK1 and CK2 for me, for my problem? What is the best for my problem? Okay. Now, we know how to create this pk. So, now, we know how to create the pk. So, we know how to create this pk. That's pk we know how to create now. Pk is a V0k, that V0k times any arbitrary ck. And this V0k comes from your single variety decomposition of your gamma k. Well, I want to explain this because this is very practical technique we used in NASA to design our controller. Explain to you a very useful technique. Very simple to write your side output is simple. Now, this phi k is like this. I have 1, 2, 3, 4, 4 elements like this. But the matter of fact that for this problem, half of that is half that is for my half that, if you look at carefully, have this guy half. That is for my cross eigenvectors. And another half is for this problem. And for this example, for your homework example, half of that is for my eigenvector, half that is for my gain. I can compute that. So if you look at the screen, define phi k into two parts. One is phi k bar, one is a phi k head. Right. And for that, erase that. So that I have space to explain what does that mean on the screen. Okay, so for that, because the full K is long, that full K can be divided into two terms. One is the full K psi K. That's my closed eigenvectors. So the other part of my phi K will be my closed loop eigenvectors. My lower part will be to solve for the gain. Alright. For example, I'll just give you an example. If my V0K is 4 by 2, that's how I got, right? Time the CK is 2 by 1. For this case, then I have this phi K, that's my psi K, and this FC times my psi K, let me write again, sorry. I divide this as two parts for this case, and that's my phi K bar, and this is my phi K hat. And this is 2 by 1, and this is 2 by 1, and that also equal to my psi K on my FC, psi K, right? Well, this is come from the key equation I show you, and this come from single value decomposition. This come from SVD, and this come from theory, right? So, if I do this, then I will be able to write the FC psi K equal to phi K hat, and psi K equal to phi K bar. Alright. Alright, so this is the example use of 4 by 2 and give you this is your homework. That's your homework. So your homework dimension will be like this. So keep in mind your homework dimension will be like this. And your homework dimension, this will be 2 by 1, and this will be 2 by 1 too. Alright? Like that. So we have one piece, we have this piece by SVD and that piece by theory, by your key equations. So again, because K for this case, K equal 1 and 2. For 2 by 2 case, that K is only 1 by 2 by 4 by 2 and 2 by 1. That's your homework case. Now I'm trying to solve the homework for you. Alright. And FC, so FC times times 3 1, wait a second. Yeah. Because that equal now. This equal to that equal to that. So FC 3 1 bar and 3 2 bar equal to 9 3 head and 3 2 head. Because the 2 by 2 problem will go in 1 2 1 2. Eigenvalue 1 and eigenvalue 2. And again here, I think this computer cannot install a mass type. Okay, I think that's the problem. Alright, so this is head, this is a head, and this is a head. Alright? And your nose should be right. And if you do that, then we'll have this one now. If you carefully, this one will be, this will be 2 by 2. Each one 2 by 1. And this one will be 2 by 2 too. For your homework problem. And that's R by N. R by N, homework R equal 2. So, bye-bye. I think your homework is 2 by 2. No? Let's see. Yeah. Your homework, I think so. Well, okay. Well, I assume your A is 2 by 2. Your homework is 4 by 4. So your homework is 4 by 4. So this is 2 by, this is 2 by 2. Okay. Well, this example is 2 by 2. Your homework A is 4 by 4. Okay. So your gain will be, for that, then you can solve your gain out. And your gain is simply this head, and this head, and this alpha inverse. That's yours. Now, however, I want to note the closed loop, eigenvector should be as independent as possible to avoid your conditioning problem. That means we have an inverse. Now we have an inverse here. Now if we have an inverse here, you have to be careful of the inverse. When you have matrix inverse, you're going to make sure your matrix is good condition, so your inverse will be good. So your inverse here. And I will show you how can I do that and make sure my inverse is good. How can I choose? This is involved to choose what? This is involved to choose this